Hi everyone, Mrs. Smeagol here. We are going to recap what you learned in the Beaker's notes on naming ionic chemicals. So you need two things for this video. You need your Beaker's notes packet, and then you also need your ionic bonding Cornell notes, the ones that we started in class last time. There should be a section for this video in those notes. All right, I want you to take a second to look at this chart in your notes. These should be in your ionic bonding Cornell notes, but it says names and formulas of some ionic compounds, and then they give you formula, and it says chemists write. So here's what chemists would write to describe a chemical, and then the name is what chemists say. So here's how we would actually read the name of this chemical. Here's some more formulas that chemists write. Here's some more names that go with those that chemists say, and then a third column of chemists write these formulas. Here's what they say. So I want you to just pause the video and take a second and just look at this list and make some observations. No, really, pause the video just for a minute. Okay, hopefully you actually listened and made some observations looking at the patterns. We're going to answer these questions. So how does the ending of the second element change? So that's like this guy, this guy, this guy. So if that second element is a non-metal, we drop the ending and add "-ide," kind of like we did with when we did covalent bonding. Okay, when does capitalization appear to be important? I notice that some of the chemical names have capitals, some have lower cases. You can see there's some differences. So it must not matter if we have capitalization in the name, whereas the capitalization seems very important in the formulas. Every element has one capital letter, and if there's a second letter that's lowercase, it's important that that letter stays lowercase, otherwise it looks like a new element. So the capitalization is important in the formula. Oops. Then, do the subscripts, tiny numbers in the formula appear in the name? I don't see any prefixes, anything in the names that indicate, nothing here that indicates how many numbers. Look at, there's a 2, just says fluoride. So, no, there's no tiny numbers or indication of those numbers in the name. The first element is always a metal. The second element is always a non-metal for ionic bonding. So hopefully that's a good recap of what you've seen so far in Beaker's notes. So for this section, you're going to need your Cornell notes, and you're going to need Beaker's notes page 1. The combination that we're going to talk about in Beaker's notes page 1 is when we have a type 1 metal bonded with a non-metal. So here's Beaker's notes page 1, just to refresh your memory. And again, these are going to be, and you can even write this on your Beaker's notes, type 1 metal plus non-metal. All of these have the same pattern. So what is a type 1 metal exactly? We know metals are on the left side of your periodic table, but a type 1 metal is a metal that we can use the periodic table to determine the charge. So the alkali metals are +1, the alkaline earth metals are +2, and there's a couple other examples that are always the same. Aluminum is +3, zinc is +2, silver's +1, and cadmium, I believe, is +1 also. Hold up, I just double checked myself. Cadmium is +2. Something didn't feel right when I said that. There we go. So I want you to write in your notes that what the type 1 metal that we can use the periodic table to determine the charge. So it's an alkali metal, which are +1, alkaline earth metals are +2, and then write down these 4 with their special charges. Aluminum is always +3, zinc +2, cadmium +2, silver +1. Here's how they work. When we write the name of a type 1 metal, non-metal ionic compound, the metal comes first, and we do not change the metal's name. So if it's silver on the periodic table, we spell it as silver. For the non-metal, we drop the ending and add "-ide." Okay, then for the formula, when we want to write the chemical formula, the metal comes first, and we get the charge of the metal from the periodic table. The non-metal comes second, and you determine the charge of the non-metal from the periodic table. For example, if I'm going to bond calcium with chlorine, I find calcium on the periodic table. It's in group 2, the second column, has a +2 charge. I find chlorine on the periodic table. It has a -1 charge. Now, the steps say to crisscross the charges and remove the plus and the minus sign. Here's what it means by crisscross the charges. This 1 is going to go down to chlorine, so Ca1, and this 2 is going to go down, this 1 goes to calcium, and the 2 goes to chlorine, Cl2. Notice I moved these high charges down as small subscripts, and I got rid of the plus and minus sign. The subscripts, the 1 and the 2 here, represent the number of atoms needed to make the compound neutral. Now, in chemistry, chemists don't usually write the 1, so it would just be CaCl2, but I would never mark you off if you wrote Ca1Cl2. Now we're going to try these ones. So we have magnesium and bromide. So we find magnesium on the periodic table. It's the metal and it's in group 2, so it has a +2 charge. And bromide sounds a lot like the nonmetal bromine. That's exactly what it is. Bromine has a -1 charge. Now we're ready to crisscross. The 1 goes to magnesium, Mg, but I'm not going to write the 1. The 2 goes to bromine, Br2. So there's your chemical formula. Make sure the capital for M, capital for B, the other letters are lowercase, and your 2 is a small subscript. Now we have calcium oxide. Calcium is another one that's +2. Oxide sounds like oxygen. It is -2. When I crisscross these, the 2 and the 2 become Ca2O2. But if we can reduce, it's kind of like a fraction, 2/2, we can simplify. Or another way to think about it is a +2 charge and a -2 charge cancel each other out. So we're going to actually cancel these 2's, and my chemical formula is going to be CaO. So if you have a +1 and a -1, they will cancel. A +2 and a -2, they will cancel. A +3 and a -3, they will cancel. Now, potassium phosphide. Potassium is a +1 charge. It's an alkali metal in the first column. Phosphide sounds most like phosphorus, P-3. Now we're going to crisscross. The 3 goes to potassium, so K3, it's a subscript. The 1 goes to phosphorus, P, and I'm not going to write the 1. For naming, the type 1 metal, that's first, so this guy, it keeps its name. So I'm just going to look at the periodic table and spell the element name as it's spelled on the periodic table. Barium, and then my second element is a nonmetal. We don't need prefixes for ionic bonding, so we just drop the ending and add "ide." This becomes barium nitride. The reason we don't need prefixes is because if I give you the name like we did up here, we crisscross the charges to find the subscripts. That's not something we did with covalent bonding. Okay, then we have a type 1 metal, because I know the charge from the periodic table, and then a nonmetal. So this one, the type 1 metal name stays the same, lithium, and instead of iodine, we drop the ending and add "ide," iodide. So there's your Beaker's Notes page 1 recap. All right, turn in your Beaker's Notes to Beaker's Notes page 2. This is where we have a type 2 metal bonded with a nonmetal, and I'm going to explain what a type 2 metal is in a second. On the top of your Beaker's Notes page where you had your rules, I want you to label this page as type 2 metal plus nonmetal. And hopefully what I go over matches some of the rules you noticed. So first of all, put this in your Cornell notes. You probably didn't have the name of this when you did Beaker's Notes page 2. A type 2 metal is a metal that we cannot use the periodic table to determine the charge. So those are the transition metals like copper, gold, things in the middle of your periodic table. Those are the ones that have variable charges, so the charges are not always the same, so the periodic table does not help us. So write down in your Cornell notes what a type 2 metal is. When we write the name, the metal's name goes first. The metal's name does not change, just like before, but we add Roman numerals to represent the charge of the metal. And the nonmetal is just like before, drop the ending and add "ide." We might need to do something called a reverse crisscross to determine the charge for the metal, and I'll show you exactly how to do that in our examples. Okay, for the formula, the metal goes first. We determine the charge of the metal from Roman numerals this time, not from the periodic table. Nonmetal comes second, and we do get the charge of the nonmetal from the periodic table. Just like before, we're going to crisscross, get rid of the plus and minus sign, and the subscripts will represent the number of atoms needed to make the compound neutral. So everything is almost the same. The only difference is the charge of the metal comes from Roman numerals, and when we write the name, you have to figure out what the Roman numerals need to be. I'll show you how. All right, we're going to do the easy part first. So iron 2 bromide. This is a type 2 metal because I see the Roman numerals. Type 2 metal, and bromide, when I see that ending "ide," that tells me nonmetal. So type 2 metal, we're going to find iron and get the symbol on the periodic table. Fe is a capital F, lowercase e. But the periodic table does not give me the charge. This gives me the charge. It has 2 valence electrons and a positive 2 charge. It'll always be positive for the metal. Bromide sounds a lot like bromine. It's Br, and we get the charge from the periodic table. Now we crisscross. The 1 goes to the Fe. I'm not going to write the 1. The 2 goes to the bromine. So we get FeBr with a subscript 2. Now, manganese 1 oxide, same thing. Manganese is an type 2 metal, and so we use this 1 to give us the charge of +1. It's always positive for the metal. Oxide, it ends with "ide." That's a nonmetal. Oxide sounds a lot like oxygen. We get the charge from the periodic table, and we crisscross again. This 2 goes to manganese, Mn2. This 1 goes to oxygen, but we don't write the 1. Now, here's the trickier part. Copper. If I find copper on the periodic table, I see it's a type 2 metal. Chlorine is a nonmetal. So here's what I'm going to do. For type 2 metals, we leave the name the same, copper, and we need to add Roman numerals. So I'm going to leave space in parentheses for Roman numerals, just like you see Roman numerals up here. Then we have chlorine. For nonmetals, we keep the name the same, except we drop the ending and add "ide." Now, here's the tricky part. We need to find the Roman numerals. So what I'm going to do is I'm going to do what's called a reverse crisscross. Right now we have CuCl2. I am going to take this 2 and bring it up as the charge of copper, Cu plus 2. I'm going to bring this imaginary 1 up as the charge of chlorine. We need to double check, is chlorine's charge on the periodic table -1? Yes, it is. That means in this problem, copper's charge is +2, so we're going to put a 2 Roman numeral after copper. II is the Roman numeral for 2. Let's try the same thing here. Nickel is in the middle of the periodic table. It's a type 2 metal, and oxygen is a nonmetal. So we have nickel, Roman numeral, oxide. Change oxygen to oxide. Now we're going to do our reverse crisscross. So we have Ni2O. This 2 goes up to oxygen, O minus 2. This imaginary 1 goes up to nickel, Ni1. So check on the periodic table. Is oxygen -2? Yes, it is. That means nickel's charge has to be +1. So we do a Roman numeral 1. Nickel 1 oxide. All right, and lastly, Beaker's Notes, page 3, is any ionic compound that has a PAI, that stands for polyatomic ion. So let's label for this page, we have ionic with PAI, polyatomic ion. All right, so if you look, there's lots of combinations. We could have the metal first, the positive metal, bonded with a negative polyatomic ion. We could have a positive polyatomic ion bonded with a negative nonmetal, or we could have a positive polyatomic with a negative polyatomic. So it always goes positive, negative, positive, negative, positive, negative. So just for your notes, your Cornell notes, you need to label a polyatomic ion, or PAI is how I abbreviate it, is a group of atoms that has a charge. Okay, when we write the name of ionic compounds with polyatomics, the positive charged ion goes first, whether it's a metal or a polyatomic. If the positive charged ion is a polyatomic, you keep the polyatomic ion the same as it is on your list. The negative ion goes second, whether it's a nonmetal or a polyatomic. If the negative is a polyatomic, the polyatomic name does not change. It stays the same as it is on your list. So naming polyatomics are actually nice as long as you have that list. For the formula, for the positive charge ion goes first. If it's a metal, you get the charge from the periodic table or Roman numerals. If the first thing is a polyatomic, you get the charge from the list. The negative ion comes second. If it's a nonmetal, you get the charge from the periodic table. If it's a polyatomic second, you get the charge from the list. Crisscross charges like always, but with polyatomics, you have to put the new crisscross number outside the parentheses. So you always keep the polyatomic exactly as it is in the parentheses. I'll show you on the next slide. All right, so we're going to go through each of these. And so to start, we have sodium. Sodium is a type 1 metal. And I know it's type 1 because I can see the charge from the periodic table. And then I see something in parentheses here, SO4. That's my polyatomic ion. So a type 1 metal is easy. You don't need Roman numerals. all you have to do is spell it exactly as it is on the periodic table, so sodium. And then for SO4, I'm going to look at my Beaker's notes and find the polyatomic that has the formula SO4, and that is called sulfate. So I spell that exactly as it's spelled on the chart on Beaker's notes, page 3. Now, the next one, my guy in parentheses, my polyatomic is first, and then chlorine is a non-metal. So when we have our polyatomic first, we look on our polyatomic ion list. We look for the grouping of NH4, and that has a name called ammonium. And then with nonmetals, instead of writing just chlorine, we change the ending to chloride. So ammonium chloride. This one has a polyatomic bonded with another polyatomic. So you have a positive charge polyatomic bonded with a negative charge. We already did NH4, that's called ammonium. For the second polyatomic, we look on our list, and this one is called hydroxide. Okay. All right, now we do the crisscrossing. Magnesium, I find on my periodic table, it's a type 1 metal. And I know it's type 1 because I can get the charge from the periodic table, so Mg plus 2. And then phosphate, when I see something ending in 8, ATE, that is a good clue it's a polyatomic. If it were a non-metal like phosphorus, it would be phosphide. So we're looking for phosphate on my polyatomic list. It is capital P, capital O, subscript 4, so 1 P and 4 O's in parentheses, and the charge is -3. Now we're ready to crisscross. The 3 goes to Mg, so Mg3. Now this 2 goes outside of the parentheses. I have to keep the polyatomic exactly the same. Capital P, capital O, 4, close parenthesis, the 2 goes on the outside. Next we have ammonium. Ammonium is a polyatomic ion. And carbonate, 888, that is a polyatomic ion. So I'm going to be going to my polyatomic list. Ammonium is capital N, capital H, subscript 4 with a +1 charge. Carbonate is capital C, capital O, subscript 3 with a -2 charge. When we go to crisscross, the 2 goes to the ammonium, so in parentheses NH4, close parenthesis, 2. And then the 1 goes to the CO3, so we do parentheses CO3, close parenthesis, and we're not going to write the 1. All right, so here's a really good recap. For ionic bonding, we always have a positive ion first attracted to a negative ion. That's how they stick together. If you're in the first position, you can have any of these 3. Any of these could be positive. So if you have a type 1 metal, we keep the name the same as it is on the periodic table. If it's a type 2 metal, we add Roman numerals to tell us the charge. And if it's a polyatomic, we keep the name as it is on the list. So really, the only thing we're changing for metals is you might have to add Roman numerals. Then, for your negative ion, for nonmetals, we're going to drop the ending and add "ide." And for your polyatomic ions, we keep the name like it is on the list. So that's a good summary of what you have to do. You're always going to have something from this list, and then your second item will be from this list. All right, now you should have this practice packet. And so what we're going to do today is work on this first part, like these first 4 columns, 5 if you count the beginning. So essentially, you're going to write the symbols with the charges. Some of the symbols, you get the charge from the periodic table, like calcium and bromine. Some you get from Roman numerals. Then you're going to write the formula. This is after you crisscross. Okay, the naming rule. All of these are ionic, so you can put ionic in every box, but then I also want to know what are the 2 things. So you can look back on the previous slide. It should be one thing from the first list, type 1 metal, type 2 metal, or polyatomic, plus one of the 2 things from the second list, non-metal or polyatomic. You can write the name using the naming rules then that we just recapped in this video and you learned in Beaker's notes. Don't worry about this column. You're going to do that a little later today. So here's the second page. Once you finish the first page, you're going to continue on to the second page. And then here's the last page. So your goal is to get as far in these as possible today. All right, hopefully that video was a good recap of Beaker's notes for you.